Welcome to The Explainer. Today we're going to talk about something really cool. It's a new framework straight out of the journal Biosystems that basically flips our whole idea of intelligence on its head. It argues we need to stop looking at pure computer power and start looking at the messy, beautiful world of, well, biology. So let's just jump right in with a question that I think gets to the heart of it all. We see these AI systems doing incredible things, right? But doesn't it feel like something's missing? Like, deep down, we know there's a huge difference between a living, breathing mind and a super complex algorithm. So, what is that difference? Well, the paper we're digging into today, it's called the Reaction to Reflection Model, or R2R for short, says the answer has nothing to do with processing speed or how much data you have. Nope, it's about something completely different, a new way to measure genuine intelligence. And that key idea is something called recursive depth. Okay, to really get what they're talking about, we've got to kind of shift our thinking. We need a totally new way of looking at intelligence, something that goes way beyond just, a checklist of abilities. Think about it. For years, we've basically defined intelligence by what a system can do. Can it solve this puzzle? Can it recognize a face in a photo? It's all about skills. But this R2R model, it says that whole checklist approach is missing the point. It's missing a much, much deeper principle that holds it all together. And here's what that old view totally forgets. For us, for every living thing on this planet, intelligence is tied directly to survival, right? We have real-world problems. We need to find food, we need energy, we need to stay alive. There are real stakes, and it's those stakes that's what gives information meaning in the first place. So that brings us right back to the core idea of this whole framework. If intelligence isn't just a list of skills, then what is it? Well, the secret, they say, is all about a very specific type of recursion, and they call it true recursion. Now, this isn't your simple feedback loop, okay? It's not like a thermostat that just clicks on and off. No way. In a truly recursive system, every single cycle changes the system itself. It's constantly learning, adapting, literally rewiring itself from the inside out. It's a process of, well, progressive deepening. And the model gets super specific here. It lays out 3 roles, 3 things that have to be true for this to work. 1, the system has to be able to change itself. 2, each learning cycle has to build on the last one, making it more and more sophisticated. And 3, this is the big one, it all has to be anchored in biology. It needs a body with real-world needs and goals. So, you're probably wondering, where did this kind of intelligence come from? Well, it didn't just pop into existence. The R2R framework suggests it actually evolved through 4 huge leaps, 4 major transitions, with each one getting more and more recursively complex. And this journey is pretty incredible. It starts with the absolute simplest chemistry that just reinforces itself, and then it builds layer on top of layer, all the way up to, well, to us, to complex, self-aware thought. So let's walk through these 4 stages. Okay, stage 1, reaction. We're going way back to the very beginning of life here. This is where you have these basic chemical cycles. Think of the primordial RNA world that created the first super simple self-sustaining loops. This is the absolute foundation, the bedrock of all biological intelligence. And you can still see this kind of thing in action today. The slime mold is a perfect and kind of weird example. It moves around by leaving a chemical trail, and then it uses that trail to know where not to go. That's it. It's a super simple external memory. It's a recursive loop where its past actions literally change its future behavior. And get this, it does all of this without a brain, without a single neuron. How cool is that? All right, on to the next massive leap. Stage 2 is called temporogenesis, and this is a game changer because this is where life learns to use time. Instead of just reacting to the present moment, systems start building internal models to actually predict and get ready for what's coming next. I mean, just think about your own internal body clock. That's a great example. But the paper points to something even more fundamental: cyanobacteria. These tiny organisms have their own 24-hour molecular clock. And it's not just reacting to sunlight. It's a totally self-sustaining, recursive process that anticipates the day-night cycle. And that gives them a huge survival advantage over anything that can't do that. Okay, stage 3, symbiogenesis. This is basically where different systems, which are already intelligent in their own simple, recursive way, team up. They merge together to create something brand new and way more powerful than just the sum of its parts. The classic example of this, of course, is how ancient bacteria teamed up to become the complex cells that make you, you. But what's really cool is that the R2R model says the exact same principle is at work inside our brains. All these different specialized parts, for seeing, for hearing, for moving, they all integrate together to give us this one smooth, seamless experience of reality. And all that teamwork, that integration, it sets the stage for the final and honestly, the most mind-blowing transition of all, cognogenesis. This is the big one. This is the leap that the model says explains where consciousness, self-awareness itself, actually comes from. And to understand this, you have to get this one key difference. It's probably the most important idea in the whole paper. It's the difference between implicit and explicit recursion. With implicit recursion, the system is the loop. Think of the slime mold again. But with explicit recursion, the system can see the loop. It can actually think about its own thinking processes. It can reflect on them and then decide to change them. That's a whole new level. This idea, which builds on the work of giants like Douglas Hofstadter, is just so powerful. It suggests that consciousness isn't some kind of magic spark. It's something that just emerges when a system gets complex enough that its recursive loops can turn back in on themselves, when it can start to think about its own thinking. Okay, so what does all this mean for AI? If we start looking at intelligence this way, what does it mean for the future? Well, the implications are, frankly, huge. So this table lays out 5 huge differences between this biological intelligence and what our computers do. Take the first one, self-modification versus optimization. A living thing actually changes its own internal wiring based on what happens to it. An AI, it just gets better at a task within the rules it was given. Or look at biological grounding versus abstract processing. Our intelligence is grounded in survival. We need it. AI is just shuffling symbols around that don't mean anything to it. And this pattern holds true for how they integrate information, how they experience time, and where their motivation comes from. And the big takeaway here is that just making our AIs bigger and faster, well, it might be taking us in the completely wrong direction if consciousness is the goal. Which really brings us to the bottom line here. According to this model, real intelligence can't just be coded. It can't be programmed from the outside in. It has to be grown from the inside out. Inside a system that has a body, that has real needs, a system that actually has something to lose. And so that leaves us with one last really provocative question to think about. If a body, if real stakes are absolute requirements for the kind of intelligence that leads to consciousness, then can we ever build a truly conscious mind inside a computer? This whole framework seems to be pointing towards a very clear, and maybe for some, a very disappointing answer. No.